Good afternoon, Year 10s. I think it's afternoon. I believe it is. Period 6. Sorry I couldn't be there today. I was pulled out for a check-in day just to see how I'm going with my teaching over the first week. But basically, you guys are going to be walking through the lesson as though I was there. So just starting, what we're going to do today, we're going to look at some logarithms. Logarithms is quite a big topic. This lesson we're going to start with logarithms, and next lesson we're going to get into the rules of logarithms. This is going to be really important, especially for your PSMT, I believe. But having a look, let's get started. Learning intention. To understand what a logarithm is and how to convert between index form and logarithmic form. To be able to evaluate and use logarithm in scale measurement. Success criteria: I can convert between index and logarithmic form, and I can evaluate logarithms in scale measurement. Right, so if you're going to pause the video, write that down just so you guys understand what we're going to be doing, what we're working towards. All right, awesome. Okay, let's have a look here. So, logarithms. How fun. Let's have a look here. Let's go back up. Sorry. So, logarithms. All right. To index, power, or exponent in a statement, y equals a to the power of x is also known as a logarithm, or log for short. So, as we can see here, logarithm or index or power or exponent is our little power 2 symbol up here. And we know our base is our value here, right? Okay. So this statement, y equals a to the power of x, can be written in an alternate form as log a or log base y, so our value here goes into our value here, equals x. So our power goes to our equals value, which is read as the logarithm of y to the base a is equal to x. These two statements are equivalent. So, as you can see here, this form converts into this form here. So this is our logarithmic form. So, for example, 3 squared equals 9 can be written as 3 to the log, log to the 3, 9 equals 2. So let's do a little example over here. A little just, here we go. So we'll write our form, y equals our x, our a to the x. And how that can be written as, right? So what we're going to do is we're going to write out our log. We're going to bring down, what value are we bringing down? Our base value. So we're going to bring this one down. And it's going to come down here to our a. So this is going to go here. Then our next value that we're going to bring down is, what's the next value that we're going to bring down? Our y. So these are going to swap. Log a to the y is going to equal our x value, equal our x, right? And vice versa. So you can do this opposite ways, whether you're given the log equation or the base equation, right? Okay. Let's look at a work example. So, write the following in logarithmic form. Let's have a look. Before we look at this one here at the bottom, let's try and do this one ourselves. So we've got 10 to the 4 is equal to 10,000. 10,000. Oh, awesome. All right, so looking up here, we know we can start with writing our log value, right? The next one we're going to use is our a value. Looking here, which one is going to be our a value? It's going to be our 10 value here, right? So that's what we're going to bring down. That's going to be our bottom power, log to the 10. We then know the next value brought down is our y value. And this value here, this 10,000, is our y value. So we're going to do log 10 to 10,000 is going to equal to our what? Our x value. So our power or our component. So we're going to bring that 4 down. It's going to be equal to 4, right? That's how we're going to write it. That's it. Done. Leave it as that. There's a second example there. 6 to the power of x is equal to 216. And as you can see down here, they've done the same thing. So they've converted it down. So they've brought the 6 down, the 2016 down, and the power value over here, right? Okay, another quick example, just so we can get the hang of it. Now we're going opposite ways, right? So instead of going from our given index form to our logarithmic form, we're now going from our our logarithmic form to our index form, right? So, looking over here, let's write this one out. So we've got log 2 to the 8 equals 3. Okay, so going back up to the top, we can see we've got our reversed value here. So our y value is going to be, our starting value here, our 8. So we know that 8 is going to be equal to, our a value is our base value of our log, which is 2, which leaves us with our 3 power, which is to the power of 3. And we know that 2 times 2 times 2, because 2 to the power of 3, is going to be equal to 8, right? They've done the same thing over here, and they've done a second question here with our log to the bottom 25, 5 equals half. They've done the same thing over here, right? All right. Second point, using logarithmic scales in measurement. So, logarithms can also be used to display data sets that cover a range of values which vary greatly in size. For example, when measuring the amplitude of earthquake waves, some earthquakes will have the amplitude of 10,000, whereas other earthquakes may have amplitudes of 10 million, 1,000 times greater. Rather than trying to display this data on a linear scale, we can take the logarithm of amplitude, which gives us magnitude of each earthquake. The Richter scale uses the magnitudes of earthquake to display the difference in their power. Sorry if you hear that, my sister is coming home from basketball training. So let's look at the worked example here. Convert the following amplitudes of earthquakes into values on the Richter scale. Correct to 1 decimal place. So look at question A here. 1989 Newcastle earthquake. Amplitude 398,000. Let's have a look here. So what they've done is in that calculator, they've put in log 398,000 equal, and they've got their answer. Pretty easy. All you're going to use is a calculator for this one, just popping it in. A little tip here, something that can be used is when we're going to look at our log value, 398,000. What we can see, if there is not a value here, what we can assume is that is going to be a 10, right? So when there's no value, it's assumed that it's going to be log to the 10, right? There's always going to be a 10 there when there's no value shown. Same as when you put it into your calculator, it's going to assume as log to the 10, right? They've done the same thing for the rest of these three. Just pop log with the answers into their calculator, and they've been given a result. All right. That's basically the topic today for logarithms. Pretty easy, pretty quick. Just an introduction to it all. We've got a few example questions here. I'll go through one to start now. So let's do question 1A. 1A. Let's have a look here. 4 squared equals 16. And it wants us to convert it into logarithmic form. Right. So we know we've got our log to the power of our base. 2. How easy is that? Right? Just like that. And we can double check this by looking up here. Let's have a look. Right. So our A value down, our Y value down, and our X value down. A value down, Y value down, X value down. Easy as that. Go on to do questions 1, 3, and 5. Do every second one for this. And then complete questions 2, 4, 6, and the remaining as they are. If you guys have any troubles, just let me know, email me. I should be able to answer them that night, or I'll ask them in class tomorrow. But yeah, thank you all for listening. Hopefully you guys understood. If you do finish these questions, feel free to go into Jack Plus and work through some more there. But yeah.